Okay, now we're going to talk about area of a surface. And in these cases, f of xy is positive, so it's above the xy plane, and it has continuous first partial derivatives on R. Now, let me draw a picture. For R, that's in the x, D is going to be in the xy plane, a little region. And again, we're going to divide these into rectangles, little rectangles. So we'll call that R. And this is going to be delta x. And this is delta y. And we're going to take this point in that rectangle, and let's call it x0, y0, 0. And we're going to go up to this surface that corresponds to that region D. And that's x0, y0, f of x0, y0. And that's the surface. Then we're going to take the tangent plane that corresponds to R. So delta t is part of the tangent plane corresponding to R. And then you have delta S kind of right here, which is part of the surface which corresponds to R. And around that point, if you take the rectangle small enough, delta t is approximately delta S. So the surface is approximately the same as the part of the tangent plane, and that's almost like saying the tangent line in 2 dimensions is the same as the curve at that point, close to that point. So if we sum all of the rectangles and the delta t's, then we get approximately the area of the whole surface corresponding to D. So the surface area is going to be, well, actually, write this out. The surface area, the area of that surface, is going to equal the limit of all the t i's go to infinity of all the delta t's. All right, now what we're going to do, here's one of the delta t's. We're going to pick a point in the corner. And that's going to correspond to this point in R. So this is in the xy plane. R is in the xy plane. So we're going to choose the point xi, yi to be a corner point of R closest to the origin. And we're going to pick A and B tangent to the traces of S on the planes x equal xi and y equal yi respectively. So this is A, and that's B. And their slopes of the lines determined by A and B are f of x and f of y, since they're tangent. And so we can write A equal delta xi times I plus fx at that point delta xi k. And B is along delta y, and this should be j, sorry. And the area of delta ti is a parallelogram, and that's the norm of A cross B. Well, A cross B is the determinant and if we take the magnitude of that determinant, then we have the square root of and so if we take the limit and add all those up, then that's going to be the surface area. So it's going to be the double integral over that surface D of the square root of this. Oh, I forgot you can have those on the outside. And that's the dA. Okay, so that's where the formula comes from. Quickly, I mean, I just kind of outlined it. You can look at it specifically in the book. So let's do an example. I want the area of the surface in the first octant cut from x squared plus z squared equals 16 by the planes x equals 0, x equal 2, y equals 0, y equals 3. Okay, so we have that right there. Because this is a x squared plus y squared is a cylinder, if I draw that correctly, going that way in all directions. And if you want the first octant, and we cut it by x equals 0, and x equal 2, so we're getting 0, x equal 2, y equals 0, and y equal 3. So we're just getting this top half right here. Okay, to set up the integral then, we're just going to go x is 0 to 2, and y is 0 to 3, and f of x, okay, z is square root of 16 minus x squared, so f with respect to x is minus x over the square root of 16 minus x squared. F of y is 0. We'll combine them and get common denominators, so the x squareds are going to cancel out. And so this is going to be 4. Square root of 16 is 4. 0 to 3, 0 to 2. 16 minus x squared to the negative 1/2. Okay, in the first part, we're going to use trig substitution, or we could just use our trig table. Where we have the integral d over the 6a squared minus u squared is sine inverse u over a plus c. So here, this integral is going to be 4, 0 to 3, that's going to be sine inverse x over 4 from 0 to 2. Let's not integrate that. So that's just going to be sine inverse of 1/2 minus sine inverse of 0, which is pi over 6. And then we're going to integrate 0 to 3 pi over 6 dy. And then we have to multiply by the 4 out in front. And that gives us 2 pi. Okay, so there's an example of that's going to be the surface area of that region.